Hello. Hello and welcome to this video. In this video, we will solve question number 522 to 532. So we are solving 11 questions because we want to finish this in next 3 days, including today. So day after tomorrow, we will finish this chapter. Before starting, I will say that you should pause the video when I'm stating the problem and try to solve the problem yourself. Only if you cannot solve the problem yourself, you should look at the solution. The second thing is always use pen and paper when watching these videos, because if you don't write and don't solve, then it's not going to help you much. So with that out of the way, let's get started. Question 522 says that find all values of a for which the inequality 1 plus log of x square plus 1 with base 5 is greater than or equal to log of x square plus 4x plus a with base 5 is valid for all real x. So what we do first is we convert everything to base of log 5. So we write 1 as log 5 with base 5, then we multiply this and take antilog. So it becomes 5 into x square plus 1 greater than or equal to x square plus 4x plus a. We bring everything to one side. 5 minus a, x square minus 4x plus 5 minus a is greater than or equal to 0. Now, what it says is that the x should be real and we have to find a. So we have to find that this to be greater than or equal to 0. So d should be less than or equal to 0. Okay, because we want complex roots so that the graph is always positive. So we compute the discriminant, and from this we get a less than or equal to 3 or a greater than or equal to 7. The second fact is that the coefficient of x square here should be greater than 0, so a should be less than 5. Now we combine everything, we get to minus infinity less than a less than or equal to 3. But for log to be defined, x square plus 4x plus a should be greater than 0. So d should be less than 0. That means a should lie between minus 2 and 2, and a should be greater than 0. So we combine everything, we see that a lies between 2 and 3, with 3 as the closest range. Question 523 says that find the value of the parameter a for which 1 plus log of 2x square plus 2x plus 7 by 2 with base 2 is greater than or equal to log of x square plus a with base 2 is satisfied by at least one real x. So like previous problem, we compute the log in a moment. So first we have this should be greater than 0 for real x. The discriminant of the corresponding equation is less than 0 and coefficient of x square is greater than 0. So if you compute the discriminant, it would be less than 0. So we see that it is greater than 0. Now, so this log is defined for all x in real R. Now we look at the second equation. It is defined if a is positive, that is, it is greater than 0 and less than infinity. So we take the given equation, we convert a to the log form, log 2 with base 2, and then 2 will be multiplied with the second term, and we take antilog, we get 4x squared plus 4x plus 7 greater than or equal to x squared plus a, which means 4 minus a x squared plus 4x plus 7 minus a greater than or equal to 0. Now discriminant of the corresponding equation is minus 4 into a minus 3 into a minus 8. When d is greater than 0, a is not equal to 4 and a lies between 3 and 8. Okay. So the question is why a is not equal to 4. The reason lies that if a is equal to 4, this term will vanish and it won't be a quadratic equation. When d is equal to 0, a is equal to 3, 8. So with a is equal to 3, the given equation becomes x squared plus 4x plus 4. So which is true for all real x because it is x plus 2 whole square. When a is equal to 8, the equation becomes minus 2x minus 1 whole square when x is equal to half. And when a is equal to 4, the equation becomes 4x plus 3 for infinitely many real values of x. So the given equation is satisfied for a less than 4 and d less than 0. That means a minus 3 into a minus 8 greater than 0. So a less than 3 or a greater than 8. That is a lying between minus infinity and 3. So you combine all the results and you will eventually find that it should be minus infinity less than a less than equal to 8. Now we look at question 524. We have to find the minimum value of a plus x into b plus x by c plus x. Sorry, we have to prove that where x is greater than minus c is square root of a minus c plus square root of b minus c whole square. So we let a minus c is equal to alpha, b minus c is equal to beta, c plus x is equal to u. Then for square root of a minus c and square root of b minus c to be real, alpha beta should be greater than or equal to 0. And given that x is greater than minus c, so u should be greater than 0. Now let y is equal to a plus c, this section should be not be there. Let a plus y is equal to a plus x, b plus x by c plus x is equal to u plus alpha, u plus beta by u. So this becomes u plus alpha plus beta plus alpha beta by u. So the quadratic equation is u square plus alpha plus beta minus y plus alpha beta is equal to 0 because u is real. So discriminant would be greater than 0 or equal to 0. Alpha plus beta minus gamma whole square minus 4 alpha beta greater than or equal to 0. That is y square minus 2 into alpha plus beta y plus alpha minus beta whole square greater than or equal to 0. So corresponding roots would be alpha plus beta plus minus 2 square root of alpha beta, which is equal to square root of alpha plus square root of beta whole square and square root of alpha minus square root of beta whole square. But if y is less than equal to square root of alpha minus beta whole square, then y minus alpha plus beta plus 2 square root of alpha beta less than equal to 0, which is not possible because y minus alpha minus beta is equal to u plus alpha beta by u, which is greater than 0. And therefore least value of y is square root of alpha plus square root of beta whole square, that is square root of a minus c plus square root of b minus c whole square. Now we move on to question 525. If x, a, b are real, prove that 4 into a minus x into x minus a plus square root of a square minus b square is not greater than a square plus b square. So we are given that this is the equation. We write this as 4z into minus z plus k, where z is equal to a minus x and k is equal to square root of a square plus b square. So the equation becomes 4x square minus 4kz plus y is equal to 0. This should be z square, this shouldn't be x. Okay. Now z is real, therefore the exponent would be greater than or equal to 0. That is 18k square minus 16y greater than or equal to 0. That is y less than or equal to a square plus b square, and that means y is not greater than a square plus b square. Question 526 says that if beta is such that sine 2 beta is not equal to 0, show that for real x, the expression x square plus 2x cos alpha plus 1 by x square plus 2x cos beta plus 1 always lie between cos square alpha by cos square beta and sin square alpha by sin square beta. So we let y is equal to given fraction, and then the equation becomes y minus 1 into x square plus 2 into y cos 2 beta minus cos 2 alpha plus 1 minus y minus 1 is equal to 0. Now since the discriminant is real, therefore, x is real, therefore d greater than or equal to 0. That is 4y cos 2 beta minus cos 2 alpha whole square minus 4 into y minus 1 whole square greater than or equal to 0. We simplify this, we arrive at sin square 2 beta y square plus 2 into cos 2 alpha cos 2 beta minus 1 into y plus sin square 2 alpha less than or equal to 0. Roots of the corresponding equation are basically sin square alpha by sin square beta and cos square alpha by cos square beta, which are real and unequal, and discriminant is also greater than 0. So coefficient of y square is also greater than 0, so y does not lie between the roots. Question 527 says that show that all real values of x, that for all real values of x, the expression 2a into x minus 1 into sine square alpha by x square minus sine square alpha cannot lie between. This should be a, I believe. This should be a. Sine square alpha by 2 and 2a cos square alpha by 2. Give me a moment, I will note down all the mistakes of this. Okay. So we had issues in 524. All right. I'm using pen and paper. 524 solution and 525 solution. So 524, 525. Let's look at 524 solution. So 524, what error we had? I lost it. Okay. 524, there was some problem either in the question or in the answer. So we had minimum value of this before that. Okay, I'll find it. Okay, don't worry about it. 526 also has problem. Okay, I'll find the error. Don't worry about it. Now 526 is done, so we move on to 527. We have to show that for real values of x, the expression 2a into x minus 1 into sine square alpha by x square minus sine square alpha cannot lie between 2s sine square alpha by 2 and 2a cos square alpha by 2. This should be a. So we let given a fraction as y, we get yx square minus 2a sine square ax plus 2a minus y sine square alpha is equal to 0. Because x is real, so discriminant would be greater than or equal to 0. And we simplify the determinant, we arrive at y square minus 2ay plus a square sine square alpha greater than or equal to 0. And the corresponding roots are 2a sine square alpha by 2, 2a cos square alpha by 2. So y does not lie between these roots. Question 528 says that show that the expression tan x plus alpha by tan x minus alpha cannot lie between tan square pi by 4 minus alpha and tan square pi by 4 plus alpha. So we let y is equal to tan x plus alpha by tan x plus, tan x minus alpha, which is equal to p plus q by 1 minus pq into 1 plus pq by 1 p minus q, where p is equal to tan x and q is equal to tan alpha. So our y becomes qp square plus 1 plus q square into p plus q and divided by minus qp square plus 1 plus q square into p minus q. So we get this quadratic equation, and p is real. Therefore, we write this quadratic equation in form of p. So discriminant should be greater than 0. If we find the discriminant, we find the corresponding equation. Now this will have two roots, 1 minus q by 1 plus q whole square and 1 plus q by 1 minus q whole square. So we substitute the value of q, that is tan alpha. We find the two roots are tan square pi by 4 minus alpha and tan square pi by 4 plus alpha. So since roots are real and equal and coefficient of y square here is greater than 0, and hence y cannot lie between the given values. Question 529 says that prove that for real values of x, the expression x square plus 3x minus 4 by 3x minus 4x square plus a may have any value provided a lies between 1 and 7. So we write again the given fraction as y, we obtain a quadratic equation into x square and discriminant is greater than 0. So we arrive at 9 plus 16a y square plus 2 into 2a square plus 23y plus 9 plus 16a. Now determinant of this equation would be 4 into 2a square plus 23 whole square minus 4 into 9 plus 16a whole square, that is 16 into a plus 4 whole square, a minus 1 into a minus 7. Now this will be less than 0 only if 1 and 7, a lies between 1 and 7 and 9 by 16 greater than 0. So then this given equation would be 0. So the given expression can assume any value if a is between 1 and 7. That is, the roots of the equation for y will have complex roots. Question 530 says that prove that the expression x minus b into dx minus c divided by bx minus a into cx minus d will take all real values when x is real, provided a square minus b square and c square minus d square have the same sign. The similar question, we take fraction as y and we simplify, we find an equation in x. So the equation would be bcy minus ad into x square plus 1 minus y into bd plus ac. There should be an x which is missing here. There should be an x plus ady minus bc is equal to 0. Because x is real, therefore discriminant would be greater than or equal to 0. We compute the determinant, we get bd minus ac whole square y square minus 2 into bd plus ac whole square minus 2 into ad square plus bc square into y plus bd minus ac whole square. Now the corresponding discriminant would be minus 16 into ad minus bc into a square minus b square into c square minus d square. Now, if a square minus b square and c square minus d square have the same sign, the discriminant would be less than 0, and then y can assume any real value for complex roots. Now we come to question 531. Find the values of m for which both the roots of the equation x square minus mx plus 1 is equal to 0 are less than unity. So we compute discriminant, we find the value of m to be less than equal to minus 2 and or greater than 2. Now, since both the roots are less than unity, therefore f of 1 would be greater than 0. That means m is less than 2. Since both roots are less than unity, therefore 1 greater than alpha plus beta by 2. That is m is less than 2 again. So m is minus infinity to, this should be minus 2 because m is less than 2. So 532 you can solve like previous equation, and this time the roots are greater than unity. So we had some problems. We need to solve this S to be A, and then we had an extra xm there. This one, okay, 2, and there was another one typing mistake, but I'll find it. So with this, we come to the end of 53rd set of problems on polynomials and complex numbers. Not many problems are remaining, only 22 problems are remaining because there are total 554. So in next two videos we will finish this. I hope that you are enjoying this playlist and finding it useful for your studies and exams. If you have any questions, let me know in comments. If you have any feedback or suggestion, whether I should go slow, fast, or explain more or more steps in the solution are required, let me know. And do solve the problems, do the practice. And I wish you all the very best for your studies and exams. Thanks a lot for watching the video. I'll see you in the next one. Till then, keep practicing.